We spoke about the temperature being constant if there's a balance between the input and the output of the radiation. And therefore, if we take the incoming radiation minus the outgoing, it should be zero. It should be zero everywhere on the planet. But if we look now spatially at this difference between the input and the output, we see that it's not zero everywhere on the planet. On this map, we can see that we have values which are below zero in the yellows and the greens, and values which are above zero, which are in the oranges and the reds. Only at the place where we have actual zero, it means we have a balance between what's coming in and what's going out. So actually, when we look at the planet, and this is a plot of data from September 2008, we actually have an imbalance that in some areas we're getting more energy than we're losing, and in other areas the opposite. So how can this be? How can it be that the Earth's temperature is not changing overall, but we have this imbalance between the input and the output of the energy? So if we look schematically at the change of the radiation, the incoming and the outgoing is a function of latitude. Here we have from the South Pole to the North Pole on the x-axis, and the annual radiation shown on the y-axis. We see, first of all, the red line shows the incoming radiation, and obviously we've already seen we have the maximum at the equator. Both the sun is nearly vertical to the surface there, so we have the highest concentration. But as we go to the poles, we have higher albedo, also the angle of the sun, which results in less radiation coming in to the surface as we go towards the poles. But when we look at what's leaving the planet, shown here in the green curve, we see also we have more leaving the planet in the tropics at the equator where it's hotter, but and as we go to the poles, less. But if we look at the gradient, the changes in the outgoing radiation in green, they're much smaller than the changes in the incoming radiation shown by the red curve. And you can see also there are only 2 points on this plot where these curves exactly equal each other, where the incoming equals the outgoing. And only at those 2 points do we really have this balance between the incoming and outgoing, what we call the energy balance. Everywhere else on the planet we see they don't equal, and that one is higher than the other. So we can think of it that in the tropics, and this is maybe between, say, plus minus 40 degrees, we have a surplus of energy in the system. We're having more coming in than we're losing. So we actually have too much energy. It should be heating up all the time. As I mentioned before, if we're getting more in than we're losing, it should be heating up. But if we go to higher latitudes, from 40 degrees to the North Pole and to the South Pole, we have a deficit in energy. We're actually losing more energy than we're getting from the sun. How could that be? How can we have a larger cooling than the amount of energy that's actually coming in? Well, the answer is that we have transfer of heat from the tropics to the high latitudes. Whenever we have a difference in the amount of energy coming into a system, the system wants to reach some kind of equilibrium. So if we have too much energy in the tropics, the atmosphere, the oceans, the system will try to move that heat away from the tropics to higher latitudes. And by doing that, it's taking actually energy from the tropics to high latitudes, warming up the high latitudes in addition to the radiation they're getting from the sun. And therefore, the high latitudes are actually warmer than they should be if we were thinking only of the radiation from the sun. And what's causing that? Basically the weather and the ocean currents. If we look maybe first at the bottom, you can see tropical storms, hurricanes, which start off in the tropics, and they take huge amounts of energy to higher latitudes and dump that energy in the high latitudes, both through rain, through temperature, through winds. And in the top plot, we can actually see the ocean currents. And the oceans also have currents, and they stir the oceans by taking cold water from the polar regions to high latitude. So you can see these blue currents, which are taking cold water always from the poles towards the tropics. And on the other side of the oceans, we've got the warm currents, which are taking warm water, say, along the coast of Brazil. The Gulf current, the Gulf Stream are taking warm water to high latitudes. And this way, the oceans are continuously mixing the water in order to reduce this gradient, this temperature gradient, and by taking more energy to the high latitudes. So the reason we have weather and we have climate and the things are moving in the atmosphere, in the ocean, is because of this energy imbalance. The system is trying always to bring us to equilibrium, for those two lines to be sitting one on top of each other. We never achieve that equilibrium, and therefore we always have weather, storms, and currents in the ocean.